Hello everyone, welcome to the first episode of Object-Oriented Programming Pills. This will be a series of short videos for Twitter where we tackle all the concepts of object-oriented programming. The first one will be object, messages and methods. An object is an entity, a representation of a concept. We create a model using objects and its interactions. They don't necessarily have to be real objects, they can be a concept. For example, if I owe money to someone, then that's a debt. And it can be an object in our model even if it isn't a tangible object in the real world. The way objects interact between themselves is through messages. To send a message to an object, first I need to know it. That will be done through references, but we will touch bases with that topic later on. Then I need to know which messages that object understands. What can it do? I don't care how it does it, but what it is capable of doing. For example, I know my cat can eat, play with cables and purr. If I were to build a model of my cat, those will be the messages the object will understand. Then the object has definitions for every message it can receive. That is a method. You can think of it as a function or a procedure if you are familiar with other paradigms. Basically, it is which actions to take to resolve the message received. In today's video, we are going to tackle references, state, and properties. A reference is the way we know and access an object. If we want to go low level, it is basically a memory address that points to the object. Once you have a reference to an object, you can send messages to it. The state of an object is composed with all the attributes it has. This state can change over time or be constant. For example, if I have an object coffee cup, its state could be its color, its capacity, and whether it is filled with coffee or not. Clearly, its color and capacity won't change over time, but whether or not it is filled with our delicious coffee will. Our last concept of today's video is properties. An object has properties as a way to let others access its state. Properties offer a get and a set method to retrieve a value or set it. It is the responsibility of the object to determine how it will offer these properties to ensure correct and expected behavior. Following with the previous example of our coffee cup, we will have a get property to show our beautiful color and another get property to let the consumer know our capacity. But we won't allow them to set these values. On the other hand, the property is filled with coffee will offer a get and a set to allow the consumer to change its value. Unless we want to tie this change of state to another action, but that is a topic for another video. In today's episode, we are going to be learning about encapsulation, scope, and interfaces. The first fundamental pillar of object-oriented programming is encapsulation, so let's talk about it. Encapsulation is the principle of making every object owner and responsible of its own state. Basically, we shouldn't expose our state and allow others to modify it as they want. Instead, what this principle reinforces is to really think hard and come up with the minimum number of messages that our object has to understand and expose to the consumers. Of course, with those messages, our object has to be able to maintain its own state and also be useful. Otherwise, this does not make any sense. There is no point in using object-oriented programming and then making all our attributes public and allow consumers to change all our state without any validation or restriction. Our next topic is scope. The scope is basically the reach level a variable or a property has. If you are inside of a method in your object, all the variables you create in there can only be used inside of said method. If you instead define a variable or an attribute at the object level, then it will be usable from all the methods of your object. Another branch of scope is for your property accessors. You can define from where your properties can be accessed in most languages. Some options in here are private, public, and protected. We won't dig deeper into this topic right now, but keep in mind you can control who can access those properties to help you out with the encapsulation of your object. Lastly, we want to talk about interfaces. The interface of an object is the set of all the messages it can understand. This is very important and very powerful because we will later learn about the benefits of having different objects implement the same interface and how that allows us to design and develop better solutions. It is worth mentioning that in typed languages like C#, Java, or TypeScript, an interface is an even stronger concept, since it obliges to implement method definitions for all the messages described in an interface. It is more like a contract. In today's video, we are going to be touching the topics of classes and constructors. Classes are one of the most important concepts and constructs in object-oriented programming. The idea is simple though. A class is a blueprint for creating objects. In a class, we will define all the properties we want our objects to have, its state, and all the messages it will understand. For example, I have 3 cats in my house. If I want to model this in an object-oriented program, I will write a class cat and then create 3 instances of said class to have 3 objects, 1 for each cat. The class cat would have properties like the age and the color, and methods like eat, sleep, and purr. Then I will be able to interact with all my beautiful cats through messages. The next big topic is constructor. A constructor is a unique and special method that every class has to define. That's because the constructor has the definition on how an object of its class is created. In most languages, if you don't provide a constructor, your class will have one by default. That doesn't do anything specific for your class. Basically, in this method, you will put any logic that is necessary for an object to be created and get a valid state. For example, if you remember our cute cup of coffee, in the constructor of it, we will ask for the color of the cup and its capacity. Since we cannot create a cup without knowing its color and its capacity, it doesn't make any sense. And we will also default the value of filled with coffee to false, since we just created a cup. That state will change later on. In today's video, we are going to be tackling inheritance, this and super, and lastly, method lookup. Inheritance is the second fundamental pillar of object-oriented programming. The idea is to create class hierarchies based on the relationship of is-a. For example, if we want to model a payment, we could have a check class and an electronic fund transfer class. Both of them would inherit from a payment class. A check and an EFT are payments, but they are different from one another and will probably have different state and behavior, while also sharing some characteristics and an interface that will be on the class payment. We say that the class payment is a superclass and the ones that inherit from it are subclasses. With these new concepts in mind, we have to start thinking about how are we going to handle context. Because now, when we are inside of a class, I have to access to properties and methods that are inside of my class, but also inside of a superclass. The standard way to solve this is to have a keyword to reference its own context. That would be this or self in most languages. And another keyword to access things in the context of my superclass, and that would be super or base. Lastly, I want to talk a little about method lookup. Now we have hierarchies, and when an object receives a message, it has to look for the definition of a method with a signature that matches the message. The process of finding this definition through all the hierarchy is known as method lookup, and it is basically from bottom up. We will start on the class of the instance that received the message, and if there is no definition in this class, it will go up and search in its superclass, and so on until it finds a definition or reaches the end of the hierarchy, in which case it will produce an exception. That will be all for today's video. Drop a like below if you enjoyed it, and I will see you in the next episode of Object-Oriented Programming Pills. Today's video will be completely about one topic. We are going to be covering how to convey design ideas through diagrams, specifically UML. UML is Unified Modeling Language, and its purpose is to give us tools to share design and put ideas down to earth without having to code everything. An object will be a circle with a name and attributes connecting them to other objects through references. A reference will be drawn as an arrow. With this, we can create object graphs to visualize relationships and a possible scenario with a given state for our system. You can think of this as a certain point in time in a trace table if you are familiar with it from algorithms. Then we have the class diagrams. For classes, we will use a rectangle with the name on top, and then a section for attributes, and lastly a section for methods. This can be very detailed or very abstract. It depends on the diagram needs. Usually it is better to only put what is really necessary and leave details for later on when we want to implement this. But on occasions we might want to have a clear full interface for an important class of our system. We will connect classes that have a reference to another class with an arrow filled, and we will draw relationships of inheritance with an arrowhead empty. This way, we can create complex designs with hierarchies and references between classes in a visual and convenient way. I hope you understood all the basics about UML, because you are about to see much more of it both here on Twitter and on YouTube. Stay tuned for more design content. That will be all for today's video. I hope you like it. Leave me a comment below if you enjoy it or if you have any question, and I will see you in the next episode of Object-Oriented Programming Pills.